So good afternoon everyone. So as promised, we are going to have a tutorial on partial derivatives, right? There'll be a part 2 actually. And today we'll be focusing more on the chain rule. Okay, so we'll be focusing a little bit about the chain rule, okay, on partial derivatives, right? So we'll be focusing more on that. Okay, so I'll be giving some tutorials and we'll work on those. Okay, so let me just erase those first. Okay, alright, back on pen. Okay, so this is one question from the textbook. Alright, and like I said before, you guys could, once I'm done writing the question, you guys could pause the video and then follow, try to solve the question before checking on the answer that I'll be working out. So they gave us a question where we have to find, okay, we have to find dA over dt, okay, where our A is given, the area is given as a respect of R tan inverse, okay, this is tan inverse, R tan theta, R tan theta, okay, and it is given that R is expressed in terms of 2t plus 1, so 2t plus 1, okay, and theta is expressed as, the function theta is expressed as pi t, okay, so it's just a pi t, okay, so we're supposed to find dA dt where A is expressed in terms of R and theta, but R is expressed in terms of t, and theta is also expressed in terms of t. Okay, so I'll give you a minute. Actually, I'll just like let you pause this video and try to figure out. Then later we're gonna discuss the solution. How are you going to solve it? Okay, so I assumed you've paused the video and given an attempt on it. If not, we can work through the solution, so no problem at all. So first of all, do remember that dA over dt, right, is equivalent to del R, sorry, del A over del R, okay, multiplied by dr over dt. We're actually following the chain rule here, plus del A over del theta times d theta over dt. Okay, so basically what we're doing here is that we are actually doing the chain rule, meaning to say that first we consider in terms of R, right, in terms of the R, and then later I'm going to use another color here, and we're going to focus in terms of theta. Okay, so we're going to focus in terms of theta. Okay, and of course, as we know it, actually the R will somehow cross out. I know it doesn't really cross out, but it will cross out anyway, even the theta and the theta, and eventually you will get your dA dt with respect to R and from theta as well. Okay, so let's proceed. Okay, let's try to find del A over del R. Okay, so del A over del R is gonna be quite, I would say, a bit different because you actually have two parts here. Let me use blue, orange, I think orange is better. So you can see that we have one part of R right here and another part of R as well. That's the inverse tan function right here. Okay, so what we need to do, obviously, we need to do the product rule. Okay, I'm going to represent this in terms of U, I'm going to represent this in terms of V. So if you recall correctly, the product rule is just simply V du dr plus U dV over dr. Okay, so in this case our V is, right, tan inverse, right, R tan theta, and our du dr is just simply 1. okay, because we differentiate r with respect to, you know, du dr, right? So it becomes 1. It's very straightforward. And then when you have a u, okay, it's r, and then we have to find dv dr. Now dv dr is basically the derivative of tan inverse, okay? It's the derivative of tan inverse. And you know, we can treat the tan theta as a constant, okay? Like you can treat it as if it was a constant, meaning to say, like you can say it's a 2, or you can say it's in terms of 3. So you can say it's like 3r or 2r, okay, in this case, right? Now we have to first find the derivative of tan inverse, which I think I have to go and check on the table because I don't remember. So let me actually check what's the derivative of tan theta first. Tan inverse theta. Derivative of tan inverse. Let me check. Alright. Okay. So the derivative of tan is just simply, where's my yellow pen? Right. Okay, so the derivative of tan, whoops, is, let me is 1 over 1 plus r square tan square theta, okay, multiplied with tan theta, okay, because tan theta is a constant, by the way, so we differentiated the outside function. So the outside function in this case would be the tan inverse, right? The outside function is the tan inverse, which I highlighted in blue. Then the inside function, which I'm gonna highlight in, let's see, I think I'll highlight in white. I believe white would be easier to look at it. The inside function would be this one, the one I circled in white, the r tan theta. Okay, so that's how we do it. Okay, and remember that the derivative of any tan inverse function, which I've just looked up by the way, is just 1 over 1 plus x squared. I mean, if you do the derivative, obviously, right? So d dx of this is supposedly this one. Let's double check to make sure it's correct. Yeah, it's correct. Okay, so it's correct actually, right? So no problem there. I'm gonna erase this. Okay. Alright, so that is your del A del R. And then now for, if I were to simplify it actually, if I were to simplify del A del R, so your del A del R would be tan inverse R tan theta, okay, plus r tan theta over 1 plus r square tan square theta. Okay, so that's your final form. So I'm going to erase this, by the way, just to create some space. Okay, so now we'll proceed with our dr dt. So dr dt is fairly simple. It's just simply 2, right? Because as you can see, let me just highlight this one color here. Okay, as you can see, it's just r is just 2t plus 1, right? So when you differentiate it, the only thing that's gonna come out is 2, right? So therefore your answer is just 2. Hence your del a del r, all right, if I multiply with dr, okay, and I try to make this an important factor. Like I try to differentiate the difference between the del operator and the d operator, because del normally we use for which case? We use when the function is multivariable. Okay, we use it when it's multivariable, meaning to say that when a function has many variables, we would normally use the del operator to differentiate. But when we're using a d, the small d, it's actually for single variable. You understand? That means the function only has one input variable. But multivariable meaning to say that the function has maybe like 2, 3, 4 inputs. Okay, and whereas single variable usually would have one input. So that's the difference between the del operator and the d operator. So don't forget to understand the distinction between these two. Okay, so I'm gonna erase this by the way, just to okay, okay, right. Okay. So now with that being said, we will find the. Let me change the color. Let me change the color to white. So del A over del R times dr over dt. Okay, it's simply 2 tan inverse r tan theta plus r tan theta. Okay, don't forget the 2. I almost forgot the 2. 2r tan theta over 1 plus r square tan square theta. Okay, so that's the first part done. Now I'm gonna make some space for the second part. Okay. 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 So now let's find the del A, del theta. Okay. Now this is a bit more simpler actually. This one you don't have to worry about the U, you don't have to worry about the V, you don't have to worry about all this, because usually for theta, okay, let me just make a pen, right? For theta, we only have to worry about this function, right? This color is pretty difficult to distinguish. Let's choose another color. I'm gonna drag it to red. Okay. Hopefully you can see it. Now I've circled in red. I know it's a bit distracting, but hopefully you can see it. We only have to worry about this tan theta inside, to be honest, right? Basically this function, the orange function, sorry to say that. We just have to only worry about the function I've underlined orange earlier. Now I'm underlining in red. Apologies for the confusion, but we only just have to worry about the tan inverse, right? We don't have to really worry about anything else, just the tan inverse only. This r we can treat it as a constant, so this is of a constant by the way, so nothing to worry about. Okay, and then we're just gonna solve it as it is, so it's just gonna be r. All right, so again we solve the outer part. Remember, tan is just 1 over 1 plus r square tan square theta. Then we differentiate the inner part of tan. If I'm not mistaken, the derivative of tan is sec square, right? Because r is just a constant, by the way. Tan should be sec square theta. Sec square theta. But let me just double check one more time to make sure that we are correct, because I also sometimes do forget what's the derivative. Yeah, sec square, right? So it's confirmed it's sec square, and therefore your del A del theta would become r square sec square theta, right, over 1 plus r square tan square theta. And your d theta over dt is just simply pi. And why is it pi? Because again, I like to remind you that it's just a simple linear function, right? So when you differentiate it, d theta over dt, you're only left with the constant pi itself. So it's very straightforward. Therefore, let me just erase this to create more space. Okay, so I think we already know that. Okay. Therefore, your not dA, sorry. Remember, it's del A over del theta times d theta over dt. That is just pi r square sec square theta over 1 plus r square tan square theta. Alright, so that's all there is to it. You just multiply and you get the answer right here. And now for the final answer, if you were to present the final answer, so let's erase this. Okay, So therefore your del A, del theta, okay, the final answer would be 2 tan inverse, you just add them up basically, it's very straight, really easy, r tan theta plus 2 r tan theta plus pi r square sec square theta, okay, over 1 plus r square tan square theta. Okay, so that is your final answer actually. Okay, so that's your dA dt. Okay, so it should be fairly straightforward. If you have any problems or if like anything is unusual about the solution, please feel free to comment on it on the video and let me know. So we're moving on to the second question. Right, I'm going to erase this. Let me just make the brush a little bigger so I can erase it much faster. Okay. Right. So I'm going to make the brush a little smaller. Okay, go to pen. Okay. So we have our next question. And the question asked us to find del f del s. So we have to find del f over del s and del f del t. Okay, so del f over del t, right? What else? When our function with respect function xy fxy is equivalent to e to the power of x cos y, so e to the power of x cos y, and our x function is x is equivalent to s square minus t square, and y is just 2st, and y is just equivalent to 2st. Right, so they want us to find del f del s and del f del t when we are given a function of fxy, right, where x is representative of this and y is representative of this, basically 2st, right, and x is just s square minus t square. Alright, how do we do this? So first of all, it's straightforward. Just remember for del f del s, okay, we just use chain rule. It's just simply del f over del x times del x over del s plus del f over del y times del y over del s. Okay, very straightforward. Remember, you have two parts. One is due to x and the other is due to y, right? So obviously you can cancel out the x and of course you cancel out the y. So it's just basically chain rule, pretty straightforward stuff. So let's proceed and find del f del x. So del f, okay, whoops, I forgot to complete that, over del x is, it's pretty easy, just simply e to the power of x and cos y is just your constant, okay? Then not dx, del x del s, okay, it's just simply 2s. Alright, so del f del x times del x del s is just simply 2s times e to the power of x cos y. Okay, here's the thing I want to actually take your attention here. Because we are expressing in terms of del f and del s, so our x and our y must be with respect to s actually, right? So we have to, of course, right, x is equals to what, s squared minus t squared, and y is just 2st. Okay, so let's not forget that, and we will write it soon, don't worry. So let me just erase it for now. I'll just erase it because it seems a bit distracting, but once we combine everything together, we'll write it down actually in terms of s and t. Okay, so I'm just gonna have to leave it out. So let's just erase this part for now. Okay, alright. Okay, alright. So now moving on, we are also gonna find del f del y, which is just simply cos is just negative sine y, okay, times ex, and del y over del s is just 2t. Okay, it's very straightforward. It's just simply 2t, that's it. Because s gets differentiated off, we just end up getting 2t. So therefore del f del y times del y del s is just negative 2t sine y e to the power of x. Okay, now I'm going to erase this. Clear up some space, and we're going to write the actual function, right? The derivative actually, to be clear. So del f over del s. Wait, let me just erase this too, by the way, because I don't really like this extra functions. Okay, is just 2s e, okay, e s squared minus t squared. Okay, now we're putting back in the s and t, cos 2st, right, plus, okay, plus becomes minus, so 2t sine y is just simply 2st multiplied by e to the power of s squared minus t squared. Okay, let me erase this so that it will not be distracting, and therefore this should be your answer, right? That's del f del s right there. It's actually pretty straightforward, but as long as you understand the rules of what to differentiate and what not to differentiate, it should be pretty easy. Now I think we can move on and try to find the del f del t. Alright, now that's what we're interested in, so I'm gonna erase this as well. Just make this eraser bigger first, because it'll be easy to clear out much quicker. Okay, make sure the eraser's back to its original size. Okay, alright, so same stuff again, right, for del f and del t is just simply del f del x times del x del t plus del f del y times del y del t. As I said before, we have two parts. One part is with due to x, right? The x part. Another part we have to consider is the y part, right? And also, obviously, these will cross out, you know, therefore you get two parts of del f and del t, one due to x, another due to y. Okay, let's proceed. So we have del f del x, which I think we already did last time, is just e to the power of x cos y. Okay, del x del t was just negative 2t, right? Negative 2t. Because s is just a constant, you'll just get cancelled, right? So it just becomes 2t, negative 2t, and therefore your, let me write this here. How do I write this? Okay, so del f del x times del x del t is just negative 2t e to the power of x and cos y. Okay, now for del f del y, So we'll have here del f del y, okay, is just simply negative sine y e to the power of x, because e to the power of x is a constant. Del y del t is just simply 2s. Okay, I'm gonna have to erase this, by the way, just to create space. Hopefully you don't mind. So therefore del f del y times del y del t is just negative 2s sine y e to the power of x. Okay, and as I said before, we're going to actually of course replace the x and replace the y, right? We're going to replace the x and replace the y with respect to these functions right here, right? We're going to replace in terms of s and t, obviously, since we are differentiating respect to t, right? Del t. So it only makes sense to use s and t and not x and y. So with that being said, let me just erase just to get space, by the way. And then your del f del t is just negative 2t e to the power of s square plus, sorry, it's not plus, it's minus, my bad, s square minus t square cos 2st, right, minus 2s sine 2st e to the power of s square minus t square. So that's your del f del t. Okay, so these are your derivatives for del f del t, which we already found earlier. So I think this question is fairly straightforward. Just follow the rules and you can get the answers. Right, so let's erase them and let's go for one last question before we conclude this video. Right. Okay. Alright, so one more question from the book. Let me see. Okay. This is more of an application question, actually. Right? Let's see what they have here. Okay. So let me see the question. Okay. So they asked us to actually show. So they want us to actually show, to be honest, they want us to show. Wait, let me write the question nicely. Show that the total surface area okay, of the cone, which is written in terms of s, okay, by the way, it's a closed cone, so meaning to say that you have the cone surface as well as the, right, close properly. Show the total surface area of the cone has, say, of radius RCM and perpendicular height HCM okay, is given by this formula right here. So we have to show that S is pi r square. Okay, that's plus pi r square root r square plus h square. Alright, so we have to first actually show this part of the formula. We have to show how we get this. How is this possible? Alright, so we have to show how we got this formula. Alright, so that's the first part. Then we have the second part of the question actually saying that if R and H were increasing, right? We're increasing at the rate of 0.25 cm per second. Okay, find the rate. So they want us to find the rate that S will be increasing, okay, it will be increasing at the value when R is obviously at 3 cm and H is gonna be at 4 cm. Okay, so this is the question actually that's given to us by the textbook. So the first thing we obviously have to do is we have to show how we managed to get the formula. Actually, how is the surface area of a cone that has a closed surface, how is the formula simply just pi r square and pi r times the square root of r square plus h square? How do we show that? Actually, when it comes to show, they're most interested actually in this one. They're more interested in this part of the formula. How did we end up getting pi r times r square plus h square root r square plus h square? Like, how is this possible? They're more interested in this one. Okay, because this one I think is fairly straightforward. If you actually look at a cone, right? If you look at a cone, any cone right away, there is two parts of a cone. Oops, my drawing is actually very bad. Sorry about that. There is two parts of the cone. Okay, one which I'm going to be highlighting in orange, that one I'm shading right now, that is what we call the base. Okay, that is what we call the base surface of the cone. Alright, that's the base surface. And the one that I'll be highlighting in white color, okay, the one I'm shading in white, okay, this is what we call the lateral surface. Okay, this is what we call the lateral surface of the cone. Okay, let me write that nicely. Okay, and you can see that this formula I've circled here initially is related to the base surface. Okay, we all know that the area of a circle, any full circle, obviously pi r squared. There's no debate about that. And this one is the lateral surface. So they want to know how we end up coming to this formula, right? As I mentioned earlier, how did we end up coming to here? Because we know that the lateral surface is just simply, well, it's just, we know it's pi r l, right? Where L is obviously the slant height. Oh, sorry. L is just simply the slant height of the cone, right? And we know that, okay, if I need to use a different color right here, would that be clear? R is the radius, and we know that this height, the perpendicular height, is h, which I've marked in blue. If it's not clear, let me just mark it outside, h. Alright, so how are we going to show that? How are we going to explain this? Okay, I'm going to have to erase the question actually. So if you want to pause and solve it, I suggest you pause at this point and try to write out the question before I erase it, or just screenshot it. It's pretty easy. Okay, and if you can prove, then later I'll erase. Okay, so I'm going to erase it right now actually. Yeah. Okay, because we're going to do step by step. Okay, so we know that for any cone, like I said earlier, the surface area for a cone obviously is pi r square plus pi r l, right? Where L, obviously we know, is the slant height. Okay, we know there is a slant height. There's no doubt about that. But one thing we need to know is that for any cone, okay, if we are talking about any cone, if we were to draw a right angle triangle where r is the radius, L is the slant height, and h is the perpendicular height, we can actually see they're related by the Pythagorean theorem. Okay, the Pythagorean theorem. Hopefully I spelled that right. It's something I've learned in high school actually, or middle school. It's fairly straightforward. So we know that r square plus h square equals to L square. Okay, so therefore if we were to take the L, it's just simply the square root of r square plus h square. Alright, therefore we know that S becomes pi r square plus pi r. I substitute the L with this formula we just discovered just now. It's just r square plus h square. Okay, so I've already managed to show that this is the formula for the cone. Okay, we've managed to show that this is the formula for the cone, where as I talked earlier, this is obviously the base, right? This is the base surface, and this one is representing the curved surface or the lateral surface we talked about earlier. So if you're wondering what is lateral basically, if you recall in middle school, is also we call the curved surface, right? Because if you take out a cone and roll it, that's what you'll end up getting. You'll get up like this. How do I say this? It's more of like a rectangle actually of some sort, if I could imagine it right. Well, it's more of an arc. It's more of an arc actually. It's more of an arc, right? Yeah, it's more of an arc actually. Yes. And L, and this one is more of a pi r. Well, actually, I could be wrong, to be honest. This might not be correct, so we'll probably come back to it later. But the main idea here is that we want to actually just show that we end up getting pi r square and pi r square root r square plus h square. Okay, so that's actually what we wanted to show, right? So with that being said, now let's proceed to the second part of the question. So let me just erase first this thing we already managed to show. So if I'm not mistaken, the second part of the question, they wanted us to find, let me see here. They wanted us to find the del S del T. Okay. So we already know that S is equals to pi r square plus pi r square root r square plus h square. Okay, they wanted to find del S del T, okay, at the point when r is equivalent to 3 and h is equivalent to 5. Is that correct? Oh, sorry, h is actually equivalent to 4. My bad. My apologies. So what we know is that we also know that the rate of change of radius with respect to time dr dt is 0.25, correct? And we also know that the dh dt, okay, it's also 0.25. So it's a constant actually, because they mentioned 25 cm per second and 25 cm per second. So that's the rate of change of radius with respect to time, rate of change of height with respect to time. So what we know is that for del S del T, alright, it's just simply del S over del R times dr dt plus del S del H times dh dt. Okay, that's actually what it is. It's we have one part with respect to the radius, okay, and we have another part with respect to the height. So let's start with del S del R first. Let's try and find del S del R. Okay, we just need to find del S del R and del S del H, because dr dt we already have, and dh dt we already have it 0.25, 0.2 as a constant. It's pretty easy. So now del S del R, the first part, okay, is just simply 2 pi r. Okay, now for the second part, ooh, this is very interesting, because now we have pi r and we have this part. So we of course have to do product rule, right? Since we have two parts here, u and v. Okay, so I'm gonna have to break this down. So it's gonna be v du dr plus u dv dr. Okay, so it's just gonna be 2 pi r plus v is just, r square plus h square to the power of half. Du dr is just simply pi, okay, plus pi r, that's your u. dv dr is just simply half, okay, we're doing inside by outside, so r square plus h square to the power of negative half times 2r. Okay, that's about it. Then del S del R would be pi square root r square, wait, let me write nicely, it's a bit messy right now. Okay, so it becomes square root r square plus h square plus, let's see here, we have half. Let me use a different color. Let me just cancel out the terms here. So it makes it easier. So we would end up having pi r square. So just pi r square over square root r square plus h square. Okay, I think, yeah, that's how it's supposed to be. Yes, it's just pi r square over square root r square plus h square. Pretty easy. Okay, so that's your del S del R. Let me just erase that. Okay, now for del S del H. So if you're finding del S del H, it's pretty easy, because the only thing you have to be really worried about is just this part, really. Alright, you don't have to worry about this. Let me just make this eraser a bit smaller. You don't have to worry about u, you don't have to worry about v, you don't have to worry about anything else, just only this part which I've just marked in orange, we have circled in orange. Everything else is just a constant, you can forget, no worries. So it will be just simply pi r, okay, times half r square plus h square to the power of negative half times 2h. So we can obviously cancel out this 2 and 2. It's 1, obviously, I know, but we can just forget about it, and we'd end up having pi rh over square root r square plus h square. Okay, so that's your del S del H. Now, one thing to note actually is that since we're given the values of R3 and H4, I think it's wise that we substitute with R3 and H4 in the formula the right way, because then it would actually make our calculations a little bit easier. So R3 and H4. So let me just substitute them real quick. So del S del R, R3 over H4 should be what? Okay, let me just get my calculator. Okay. Alright, so I already got my calculator. Let's just compute the values. So 2 pi times 3 plus pi square root 3 square plus 4 square plus pi over 3 square square root 3 square plus 4 square. So yeah, we get this answer 64 over 5 pi. Okay, it's right now, so 64 over 5 pi. But if you want to write it in a not so fancy way, then it's just 40.21. I think I prefer to write this way, 40.21. Okay, and then del S and del H. Okay, if I were to substitute the values of R3 and H4 immediately, let's see what we get here. So just simply pi times 3 times 4 over square root 3 square plus 4 squared. So just 12 over 5 pi. Okay, 12 over 5 pi. If you want to write in a not so fancy way, it's gonna be 7.540 actually. So we're gonna write it 7.540. So we're just keeping it to 4 significant figures. Okay, so yeah, 4 significant figures, right? So let me just erase these straight away, right? Okay, so therefore your del S del T, okay, is just gonna be del S del R is just 64 over 5 pi, right? Sorry, just to remind you, this is del S del T, okay, when R is 3 and H is 4, yeah, so when R is 3 and H is 4, so that's when R is 3, H is 4, so just simply 64 over 5 pi, and we know we just times 0.25, yeah, plus 12 over 5 pi times 0.25. Ayo, what is this? 0.25. Okay, so what's the answer? So if I were to compute this together, so 64 over 5 pi times 0.25, so we get here 16 over 5 pi plus 12 over 5 pi times 0.25 is going to be 3 over 5 pi, so it's just simply 3 over 5 pi. So the total answer should be 19 over 5 pi. Just to double check here, so 16 over 5 plus 3 over 5, 19 over 5. So 19 over 5 pi, and if you wrote it again with decimals, so 19 over 5 pi with decimals should be 11.94. Yeah, 11.94. So 11.94 cm square, because the surface area per time. So this is basically the rate of change. Okay, so this is basically your del S del T at R is 3 and H is 4. Okay, so hopefully you give these try on these 3 questions I've just discussed actually, and if you have any questions, feel free to reach out to me on the YouTube comments or on WhatsApp as well. No problem, and I'll be happy to help you out. So till then, I'd like to say take care. Right, so take care everybody. Alright, and yeah, take care, and yeah. Right, all the best, guys. See you for the next video.